So here we're looking at this question. 1 joule is equivalent to 1 joule is equivalent to, so A we have this, B we have this, C we have this, and D we have this. So it's very important that you should know that joule is the unit for measuring work done, right? So 1 joule is equivalent to, we're simply looking for the other unit for joule, or in other words, we're looking at the option that is the same as 1 joule. So work done, joule is the unit for measuring work done, right? And work done is equal to what? Force times distance. So for us to find the other unit for 1 joule, we would have to express this, simplify it in fundamental quantities. After getting everything in fundamental quantities, we can now look for the other unit for measuring joule, or the other unit for 1 joule, or the equivalent of 1 joule. So we have that work done is equal to force times distance. Distance is a fundamental quantity, so we'll leave it. Force is a derived quantity, so we'll have to look for the formula of force. So force is equal to mass times acceleration. Mass is a fundamental quantity, we'll leave that. Acceleration is a derived quantity, so there is need for further simplification. So the formula for acceleration is equal to velocity over time. Velocity is a derived quantity, time is a fundamental quantity, so we would need to further simplify velocity. The formula for velocity is equal to displacement over time, right? Displacement is a fundamental quantity, time is a fundamental quantity. So with this, we arrive at the end of our simplification, right? So the next thing is to pick the fundamental quantities. Distance is a fundamental quantity, so we'll pick this. Mass is a fundamental quantity, we'll pick this. Time is a fundamental quantity, we'll pick this. Displacement is a fundamental quantity, we'll pick this. And time is a fundamental quantity, we'll pick this. Force is derived, so we'll leave this. Acceleration is derived, we'll leave this. Velocity is derived, we'll leave this. So after picking all of these, the next thing is to arrange them. If it appears as the numerator, we'll write it as the numerator. If it appears as the denominator, we'll write it as the denominator. So this will be equal to D, which is this D, times M, which is this M, times M over T. Because this T is appearing here as the denominator, so we'll write it under the fraction line. So it will appear as denominator here as well. Times this D that we have here, times D over what? This T. So this will be times T. T under, because the T is, we're writing this T under because the T is appearing as a denominator here. So it should also appear as a denominator here. So this is what we get. This is what we've gotten from this. So this will be equal to, if we arrange it better, this will be equal to M times D squared. This will be D times D. D times D will give us D squared. So that will be M times D squared over T times T will give us T squared. So this will be equal to, the SI unit for measuring mass is what? Kg. So that will be kg, kilogram. That's the SI unit for measuring mass. The SI unit for measuring distance is meters. So distance square will be what? Equivalent to meters square over, the SI unit for measuring time is seconds. So this will be seconds squared, right? So this will be equal to kilogram meter squared per second squared. So this is the other unit that is equivalent to 1 joule. So the correct option here is actually option C.